What a lot of people don't understand is that the AI revolution that we're seeing now it's decades of research culminating now. And basically what AI is a transcendence of rules-based or algorithms-based programming. In other words, if X, then Y. There's certainly more nuance to that, but it's this imperative paradigm where, we're basically having top-down programming. And that's excellent. We can send people to the moon. We can manage complex industrial processes with that type of technology, but it's quite limited in a couple ways. Firstly, it's not great at language. And secondly, it's not great at facial recognition or object recognition. These are two things that we take for granted as humans because they come naturally to us. We've evolved to do these things. We lived in tribes. We need to be able to communicate effectively. We need to be able to recognize people in our tribe. So they come quite naturally to us, but that's machinery that has evolved over millions of years, and that's something that actually takes quite a bit of rigor and effort to solve on a computer science level. And so what the result is with this imperative-based programming, these two big applications are limited, and you get brittle, inflexible applications. The big innovation with AI is the application of neural networks, big data, and LLMs in order to transcend these limitations. So when I say LLM, what do I mean? It's a large language model. Breakthroughs in techniques and also just mass scale infra, being able to imbibe the entire corpus of data on the internet has given us machines that are good at understanding human language. And that's been exceptionally impactful. We've seen sort of at the second half of 2022, we've seen this big boom in AI, and a lot of people even attributing sentience to these chatbots that are quite sophisticated, quite flexible, and have the ability to solve a lot of open-ended problems. But truthfully, they're just autocorrect on steroids. They've been trained on the entire internet, and they're just predicting what the next word is. So I'd like to just kind of demystify some of the fundamentals in this, in LLMs as an exercise. Let's start with a very simple example with a neural net. So this is optical character recognition, OCR. This has been around for a long time. So the goal is to get from this handwritten character on the left, the number 9, to the deterministic assignment of 0 through 9 on the right-hand side, right? And so we have these many layers in between. This neural network is essentially a biomimicry application that mimics what happens in humans, animals, brains. These middle layers are called hidden layers, and you can kind of see the evolution of the output as sort of like a pipeline as we move from left to right. If you look at so you look at the first layer, that's obviously the handwritten character. If you look at the second layer, you can see, the neural net is kind of breaking it down into, subsections in the pixels, in the pixel map. If you look at the next layer, you can kind of see that it's actually the strokes that it would take to write this character. You have a circle and a slash to make the 9, right? And then lastly, it's assigning probabilities and weightings and systems of equations to say, okay, if I have a circle and a slash and that's it, then most likely it's the number 9. So this principle is applied at scale with a lot of different applications. So if we abstract this concept, this ability to apply this black box of systems of equations to inputs in order to get to an output, we can get things like being able to identify the subject of a photograph in the top one, that's a coffee mug, being able to identify the subject of a corpus of text that's written in Victorian language. You can apply this principle broadly to all different kinds of media, from audio, video, image, and just text, and interconnect them with these systems of equations that are well trained that are created with well-trained neural nets. So another aspect I want to cover is this idea of vectorization. So one of the big outcomes of transformers like ChatGPT is the ability to vectorize language itself, the meaning of language itself, into mathematical representations such that we can do algebra on them. This really simple example illustrates, somewhat morbid example, if we do Hitler plus Italy minus Germany, that's generally speaking close to Mussolini. This process is essential in allowing chat bots such as ChatGPT to be able to take inputs with a wide range of possibilities of different vernacular, even different languages, distill them to a I'll call it semantic valence, or a mathematical representation of meaning, and then actually act upon them in a coherent way. So in practice, how that works is it will take in the prompt, it will actually essentially act like autocorrect. So how many people here have used autocorrect on their phone? So the way autocorrect works is it's trying to predict the next word that you say, and generally speaking, it's pretty crappy, right, on your phone. It doesn't have a lot of parameters, and that's the reason why. Now imagine if you had a supercomputer running, and it could, take into account everything you've ever said and anything anyone on the internet's ever said. That's the equivalent of what the LLM is doing. It's able to predict the next word, and it's just taking a probabilistic, distribution on what the next word will be. And that is how it comes up with its response. And generally speaking, at scale, this bottom-up system can result in really useful outputs that actually have meaningful impact. What these two are, and the interesting thing is you can actually tweak what is called the temperature, which affects how far down the probability distribution the model is willing to go. So on the left, it's at 0, so that means it's always going to pick the most probable words. So it's going to have a more bland, more conservative response. Whereas when the temperature is 5, you can see sometimes it'll do a crazy Ivan, and it'll pick the third most likely, the second most likely, the fifth most likely, and it'll and that has path dependence, because remember that it's picking, it's autocorrect picking the next word, so on. So this technology is tremendously impactful. It's tremendously useful. So now that we covered, the basics of, how AI, the basics of LLMs, how AI works, what does it all mean? Fundamentally, it means that we have machines that now have a grasp of human language, and we can use them for applications we hadn't been able to use them for before. Main use cases: customer service, law, even writing code. Someone earlier was pointing that out. Code is fundamentally language. We can use them for translation because we have this base layer of meaning that's abstracted from the specific language. Where we can have transformers that kind of just they're much more flexible, so translation is much easier. And then there's also more dark applications like surveillance and psyop.